Hello and welcome to this video tutorial. In this video tutorial, we will be examining the solutions for physics homework, PH, 1 and 2, which covers the topics of average velocity and acceleration. Please remember to pause or rewind the video as needed. Let's begin. In question number 1, we're looking at the idea of displacement. So it tells us we walk exactly 250 steps north, turn around, and then walk exactly 400 steps south. How far are you from your starting point? So I'm going to use the graph paper to kind of help me out here. I'm going to make each box 100 steps. So I go, if I were to, let's say, start here, I go up 100, 250 steps north. So the black arrow represents my northern displacement. Okay, now from that point, I'm gonna walk 400 steps south. Okay, I'm gonna do that with a different color. So I'm gonna go 1, 2, 3, 400 steps south, just like that. Okay, now with a different color entirely, I'll use gray here, I'm going to essentially draw a straight line from start to finish. I'm showing you this visually, and then I'll show you this mathematically, how we can figure out a solution to this. So if I draw a straight line from start to finish, you can see the gray arrow is only gonna be 150 steps. It's 1.5 boxes, and it's pointed south. So the solution is 150 steps south. Okay, well now here's how we can go about doing that. If we treated north as positive and south as negative, kind of like the directions that you would use on a normal grid, XY coordinate grid in a math class, up is positive, down is negative, right is positive, left is negative. So we could kind of look at it like this. Your total displacement, okay, is going to be equal to your displacement 1 plus your displacement 2. We're going to add our displacements, right? Well, our first displacement is positive because it's going up. So we're going 250, positive 250 steps. Plus a negative 400 steps because we're walking 400 steps south, right? And if you you'll end up subtracting them, right? You get negative 150 steps, which is the same thing as 150 steps going south, since negative was defined as the southern direction. Please remember to pause and rewind as needed, and also please remember to box or circle and highlight your work to separate it from your solution. So box or circle your solution, to separate it from your work. On to question number 2. Please read along with me. An automobile travels 25 miles west, then goes 45 miles east, then finally 15 miles west. How far will this car be from its starting point? Well, again, this is a displacement question. Displacement is delta x, or the change in position. Again, it will be helpful for you to draw a picture to sort out this as well. Just like we had north going in the positive direction and south going in the negative direction, similarly, east is right on a map, so east will be positive and west will be negative. So let's go ahead and take a picture of what this would look like. I'm going to go every box is 10 miles, just to kind of simulate what's going on here. I'll start somewhere in the middle, I guess, maybe right here. So go ahead and draw a dot for our starting point. And we start by going 25 miles west. So we're going 2.5 west. Okay, there's 25 miles west. And yeah, we should be labeling these as we go, right? This was 250 steps going north and 400 steps going south. Sorry about that. And now after this point, right here, okay, then goes 45 miles east. Okay, so I'm going to do a different color. And I'm going to go 45 miles east. Well, that would be essentially, what, 4.5 boxes, right? So there's the half. 1, 2, 3, 4. That puts the car right here. Okay, that's 45 miles going east. Okay, now at this point here, we're now finally going 15 miles west. So I'll do a different color there. So 15 miles west would be 1.5 boxes. Like that. Okay, that would be 15 miles going west. Now, you're ultimately going to draw an arrow from where you started to where you finished. And you can see if we zoom in on that, it is going to be, I'll do this in gray, a very short 5-mile arrow. So we're looking at 5 miles, and since the arrow is going to the right, it's going to be east. So 5 miles east is going to be our solution. Let's see if we can get this mathematically as well. Again, let's try adding our displacements. The variable for displacement is delta x. So we're going to add 3 displacements this time. We're going to add delta x1, we're going to add delta x2, and delta x3. Okay, those are our 3 changes in position. So delta x1 is 25 miles west, or negative 25 miles, plus 45 miles east, so that's a positive 45 miles, plus 15 miles west, so plus a negative 15 miles. Okay, when we add those up, so we're going negative 25 plus 45 is 20, and then 20 minus the 15 is 5. Since we get a positive answer, it is 5 miles going east. On to number 3. A car goes north a distance of 120 miles during a period of 3 hours. What is the average speed during this time interval? Okay, average speed, V bar, is found by taking your total distance, D, divided by your total time. So if we list our stuff, okay, this is going to be our distance, 120 miles. 3 is going to be our time in hours, okay, and we will get 120 miles, right, in 3 hours. Go ahead and divide that, right, and you'll get an average speed of 40 miles per hour. Now, you can write 40 miles per hour a couple ways. You can write it the standard MPH that you see on a road sign, or you can also write it MI/H. You could do it either way. On to number 4. The distance between Denver, Colorado and Vail, Colorado is 132 miles. With what average speed should you drive your car in order to travel this distance in exactly 2.5 hours? Well, again, this is an average speed problem, so we're using the same equation as question 3, looking for V bar. Again, this is our distance, and again, this is our time. So let's go ahead and plug into that same equation. V bar equals distance over time. This time we're plugging in 132 miles over 2.5 hours. Okay, and if you put that in your calculator correctly, you should get about 52.8 miles per hour. Number 5. A small cart is rolling along a horizontal surface, and you measure the cart to move a distance 3.25 meters over a time period 1.35 seconds. What is the average speed of the cart? Okay, so similarly, we're going to go ahead and use the same equation. V bar, average distance, or average speed, equals distance, total distance over total time. Okay, we're plugging in 3.25 meters in 1.35 seconds. Take a moment to plug that in your calculator. And you should be getting about 2.41 meters per second. Number 6. A block of wood, which is 12 centimeters long, is dropped through an infrared sensor designed to measure the time that the sensor is blocked. Assuming that this block of wood blocks the sensor for a time interval of 0.27 seconds, what is the speed of the block as it passes through the sensor? Is this average or instantaneous? Well, let's answer the final question first. Is it average or is it instantaneous? Well, anything that involves a time interval or an elapsed time between 2 points, that's always going to be average. So this is an average speed problem. Instantaneous measures an exact moment in time, not a time interval. So again, we're going to be using our distance over time. Okay, and now 12 centimeters does have to be rewritten though. So we have to rewrite that as 0.12. So we're going to write that as 0.12 meters. And we get that by moving the decimal twice to the left, divided by 0.27 seconds. Okay, and dividing those two, you're going to get 0.44 meters per second. Okay, number 7, read along with me, please. Suppose the problem number 6 above, the length of the block is known to have an accuracy of plus or minus 0.3 centimeters. Let's write that in meters. We're going to move that 2 decimal points to the right, and it's plus or minus 0.003 meters. While the timer is limited to an accuracy of plus or minus 0.05 seconds. Part A, what is the maximum speed you would calculate for this block based on these error limits? So here's how we'd go about doing that. Okay, so we know that the average speed okay, is distance over time. Okay, now what we want, in order to get the maximum speed, we need to have the largest possible distance with the smallest possible time. That means in the numerator, we're going to use the plus 0.03, and in the denominator, we're going to use the minus 0.05 seconds. That's going to be our combination for this problem here. So we are going to take our distance. Okay, our distance is 12 centimeters or 0.12 meters. So we're going to go 0.12 plus 0.003 meters. Okay, and on the bottom, we're going 0.27 minus 0.05 seconds. Okay, now putting that in our calculator, we are going to get 0.123 meters on top, and we're going to get 0.22 seconds on bottom. Run that in your calculator. Okay, and you should end up getting about 0.56 meters per second. Box and highlight my answer. Okay. Part B. Part B, how does the maximum speed differ from the speed that you calculated? Well, the speed I calculated was 0.44 in number 6. This is 0.56. So 0.56 minus 0.44, you can see the speed would be, the speed is 0.12 meters per second greater than the average. So I guess I really shouldn't call this average speed. I should call it maximum speed right here. V max, maximum speed, not average speed. Average speed we did in number 6 over here. All right, so the maximum speed, right, you can see is 0.12 meters per second greater than V bar, the average speed. Okay, now in part C, it's asking us to calculate the minimum speed. Now, how do we do that? Well, V min, same idea, okay? We're using distance over time, but this time to get the lowest possible speed, we want the lowest possible denominator, the lowest possible distance with the highest possible, lowest possible numerator, distance with the highest possible denominator, time. That means in this combination, we're gonna go and use the minus 0.03 meters and the plus 0.05 seconds. Okay, so let's go ahead and fill this out. Okay, so we're going to get 0.12 minus 0.003 meters on top. Now on the bottom, we're going to go 0.27 plus 0.05 seconds on bottom. Okay, so 0.12 minus 0.003. You can see we're going 0.117 meters, okay, on the top, and 0.27 plus 0.05 would be about what, 0.32? 0.32 seconds on bottom. Okay, sorry, I'm just copying and pasting this real quick. Okay, put that in your calculator. We have 0.117 divided by 0.32, and you can see we'll get a minimum speed this time of about 0.365 or 0.37 meters per second. Okay, how does the minimum speed differ from the calculated speed above? Okay, well, we can see for part D, V min, right, is at 0.37. So now I'm going 0.44 minus 0.37. You can see that V min is 0.07 meters per second less than V bar. Okay, part E, last one, how does the maximum error and the minimum error compare? Well, the maximum error is obviously greater. Than the minimum error. Number 8, an infrared sensor system is set up so that two sensors start timing when the infrared beam of the first sensor is blocked, and then the timer stops when the beam of the second sensor is blocked. Suppose the cart is moving toward the right when it blocks the first sensor, and then later the cart blocks the second sensor. The distance between the sensors is measured to be 88 centimeters, with a possible error of 2 centimeters. So that would be right here. Sorry, this would be 0.88 meters, right? And this would be 0.02 meters. We want to make sure we convert it. Okay, and the time interval recorded by the sensors is recorded to be 0.35 seconds with a possible error of 0.03 seconds. So part A, what is the average speed of the cart? Okay, well, pretty straightforward. Okay, distance over time. Okay, we're going 0.88 meters divided by 0.35 seconds. Okay, and you should get about 2.5 meters per second. Okay, again, box or circle your final answer. Now, in part B, we're trying to get the maximum possible error. That means we're getting the plus or minus value attached to this speed. So the way we figure that is, let's figure out what the maximum is and the minimum is, and we'll see what that's going to look like. So Vmax would be distance over time, but remember, it's going to be the largest possible distance and the lowest possible time. So it's going to be 0.88 meters plus, right, the 0.02 centimeters, or 2 centimeters, 0.02 meters, and the bottom, 0.35 seconds, minus the 0.03 seconds. Okay, well, that's going to end up looking like 0.90 meters over 0.32 seconds, which comes out to about 2.8 meters per second. Okay, and then same thing, let's find V min. Same idea. We want the lowest possible distance and the largest possible time. So we're going to be going, lowest possible distance would be 0.88 minus the 0.02 meters. and the time would be 0.35 plus the 0.03 seconds. Now for that, we're going to get about 0.86 meters of minimum distance with 0.38 seconds of maximum time. Okay, that's going to give you the lowest possible, which is about 2.2 meters per second. And if you look, the average is 2.5, right? And it goes as high as 2.8 and as low as 2.2. So we could say that the error is plus or minus 0.3 meters per second. Right? And all I had to do to get that is just subtract. Subtract this from this, and I get 0.3. Subtract this and the minimum, I get 0.3. Number 9. A car travels west at 35 miles per hour for a time period of 2.5 hours, then travels west at 55 miles per hour for an additional 4 hours. How far will this car be from its starting point? Well, if you look at here, you're given a speed and a time. Here you're given another speed and another time, okay? So if we're looking for the ultimate how far, okay, think about this. We're going to be using our average speed equation, but for 2 different time intervals, all right? Now, if we use the idea that velocity is distance over time, speed is distance over time, now solve for distance. Distance is going to be speed times time. So what we're going to do here, guys, is we're going to solve for distance, okay, for both sections, and then add the 2 distances together, meaning distance total will end up being distance for part 1, this is part 1, plus distance for part 2, which would involve the second segment right there. Okay, so that's how we're going to attack this problem. And if you need to see a picture of it, I would encourage you to draw that. So it might look like this. So if I draw this into 2 segments, this indicates the motion. It's going west for both. And I'm going to divide this into 2 parts. So the first part, I have velocity, okay, at 35 miles per hour. I'm writing it MI over H instead of MPH. And I have a time of 2.5 hours, okay, which means distance here would be speed times time, which would be 35 miles per hour times 2.5 hours, okay? Go ahead and put that in your calculator, and we're going to get distance 1. Okay, same idea here. This is velocity 1, time 1, distance 1. This is going to be velocity 2. We have a different velocity. Now we're going 55 miles per hour. Again, I'm writing MI/H. Time 2 is for now 4 hours, and we're looking for distance 2, which is going to be V2 times T2, where this was V1 times T1. Okay, and that's going to be 55 miles per hour times 4 hours. Okay, so we're going to get distance 2. Okay, putting that in our calculator, we will get 35 times 2.5. So 35 times 2.5 is about 87.5 miles. That's the distance we go here. And then part 2, we're going 55 times 4, which is 220 miles. So D total distance is going to be D1, that's the distance for the first 2.5 hours, plus D2, that's the distance for the remaining 4 hours. And that's going to be 87.5 miles plus 220 miles, and in which case we get Let me see. Let's see, plus 87.5. We should get about 307. We should get about 307.5. So we'll just round that up to 308 miles for number 9. Number 10. A car is to travel a distance of 225 miles in 4 hours. During the first 2 hours, the car travels with an average speed of 52 miles per hour. What must the average speed of the car be during the second 2 hours in order to arrive in its destination on time? So let's kind of break down the information given. So we are given the fact that there needs to be a total distance covered of 225 miles, okay, and a total time of 4 hours, all right? Now, this is another example, like question number 9, of a multi-part problem. Multi-part problems have 2 different parts of motion, okay? During time interval 1, something happens. During time interval 2, something else happens, right? So every time interval has a different kind of motion. Well, during the first 2 hours, you can see we're going at an average speed of 52 miles per hour. We have to figure out what is the average speed during the second 2-hour time interval. So what we're going to do is we're going to chart this up. The best way to deal with a multi-part problem is to create a chart. Okay, so the chart will kind of resemble this. This is for part 1. And this is for part 2. Okay, always chart up your stuff. And we can kind of label it like this. Average velocity 1, time 1, okay, and distance 1. Okay, and then average velocity 2, time 2, and distance 2. Okay, so now let's kind of figure out what's going on based on this. So for the first time segment, we have an average velocity of 52 miles, right, every hour. Again, I'm going to write it as mi/h. And that is during the first 2 hours, so 2h. Okay, we can find how far we went by multiplying those two, okay, and we would get 52 miles per hour times 2 hours, and you'll get 104 miles. Now, if 104 miles has been traveled in the first 2 hours, take 104 from 225. So 225, distance 2 is going to be 225 minus the 104, right? It's what's left over, and you get 121 miles. Okay, now to figure this out, we know that this is going to be the other 2 hours. So to figure this out, we're going to go distance over time. The distance is going to be 121 miles over the remaining 2 hours. Okay, in which case you'll get about 60.5 miles per hour that you have to travel for the rest of the 2 hours in order to get 225 miles farther in a total of 4 hours. That concludes physics homework number 1. I hope you found this tutorial to be helpful. Thank you and see you next time.